Hi and welcome to this on Maths prediction for the OCR Paper 6 Higher Tier Maths GCSE for November 2020. Enjoy! Hi and welcome to this on Maths prediction for the last paper. So, been a very long journey so far, going through the first two papers, and this is the final one. So you know the drill by now. You can click this link here and it will take you straight through to onmaths.com where you can try this paper online for free. As you know, every time you do it, it gives you a brand new paper with brand new numbers. So you're not just learning answers. In fact, there's some questions that are almost new questions each time. So it's really good for making sure that you get a grade at the start of really hard work, do your really hard work, do all your revision, and then you can do basically the same paper at the end to see how much you've improved. So it's a really useful tool. And as I say with all our predictions, make sure you do the work. Yes, these are based on historical data from this exam board. Yes, these are pretty accurate, but they're not going to be 100% accurate. So make sure you do the work, whether you go to onmaths.com to revise or mathseffect.co.uk to revise. Wherever you go, make sure you do the work first. Otherwise, I hope you enjoy it and thank you very much.
So inequalities, what are they? They just mean instead of x equaling something, x is greater than or smaller than something. So x can normally have lots of different values. Now, this statement here is really important. Integer just means a whole number. So we know that x can't be a half, because that's not a whole number. Now, x says here x is greater than minus 7 and is less than or equal to 3. So when it asks you to write down all the numbers that that's true for, well, let's have a think. Well, if it's if it's greater than minus 7, then it can't be minus 7. It can't be equal to it. So it's going to be minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, and 2. Now let's have a look at the other one. It says x can be less than or equal to 3. So that line there, if you look at it, that little line there, so if I do it a little bit bigger, the line that I've just drawn there says it can be 3. So we must include 3 in our answer. And that's how you get full marks. Now you probably will get 1 mark if you forget to put the 3 down or you put the minus 7 accidentally. Right, the next one I'm just going to write out a little bit bigger. Now the way we do this question is the same way as solving just a normal equation with an equals, but don't ever put an equals. There was an exam a few years ago that if you wrote an equals in it, they would give you 0 marks. So the first step is to expand the brackets. So I do smiles and rainbows, but if you've got another method, that's fine. I'll put a little line there to remind me to times it. So 5 times 3x is 15x. And 5 times minus 5 is minus 25. Now you could have divided both sides by 5 and that would have been fine. Next step is to get rid of this minus 25. And you must start with that. You can't get rid of the 15 first. So we're going to add 25 to both sides to get rid of that minus 25. So we're left with 15x on this side. And 35 plus 25 will be, well, 5 plus 35 is 40. 40 plus 20 is 60. Now to get rid of this times 15, we need to divide both sides by 15. So that will get rid of the 15 there. And how many 15s in 60? Well, 2 times 15 is 30, so it would be 4. Now be really careful not to accidentally put any equal signs in your answer, and especially this bit here. So it's x is greater than 4. Okay, so this question is asking us to find unknown lengths. Now, the easiest way of approaching this question is to draw the two triangles, the little one and the big one, separately. So I'm going to do that really quickly. I'm going to draw the small one, and I'm going to draw the big one. There we go. And I'm going to fill in the length. So this small one has 37 here, and 17 at the bottom here. This big one has 50 down the side, and 34 at the bottom. Okay, now a second most important thing to realise with this question is that these two triangles are mathematically similar. The reason is that the top angle here is shared. These two here are both corresponding because they're off a parallel line, and it's the same with these two. And any two triangles that have exactly the same angles will always be similar, which means that one's an enlargement of the other. And with enlargements, we're always thinking about scale factors. So we've got to find out what you times 17 by to get to 34. So on my calculator I do 34 divided by 17. I probably shouldn't need to do it on the calculator, because obviously the answer is 2. So if I'm timesing that side by 2, and I'm looking for length AD. Now AD is this one here. How do I get from 37 to AD? And remember, it's corresponding side, so it would be the left hand side will go to the left hand side. So times that by 2. So it would be 37 times 2, which is going to be 74. So my answer will be 74. And the last one, let's do it in a different colour. Now we're looking for length CE. So CE is a bit of a weird one, isn't it? Because CE is this bit here. So all I need to do is work out what AC is, which is this one here. So let's work out what AC is. So to go from the big one to the small one, instead of timesing by the scale factor, I'm going to divide. So I'm going to divide it by 2. So AC is 25. Now if AC is 25 and the whole thing is 50, so let's try and make this a bit clearer. So the whole thing is 50 and AC is 25. So this bit up until this bit, then CE must be 25 as well, because it's 50 take away 25, which is 25. Okay, so the main problem with this question is that people don't know what a frequency polygon is. If you know what a frequency polygon is, I think most people will get this right. Frequency polygon is basically a line graph, but you plot these at the midpoints. So the first one's going to be plotted at 40. The next one, so if you don't know how to find a midpoint, you're just finding the halfway value between 0 and 80, which is 40. To do it a different way, you could add the two values together and halve it, and that works just as well. So 80 plus 160 is 240, and then halve it would be 120. 160 plus 240 is going to be 400, halve it is 200. Okay, so we're going to plot these at 40, 120 and 200. Now a different way of doing it is just plotting them halfway between the two lines. So we've got a line here and a line here, so we're just plotting them halfway. So it says frequency is 11, so looking at the scale it looks like it's going up in 2s, so that would be 12, 14, 16, 18 and 20, so that works. So we're going to plot it halfway between the two red lines that I've just shown, and it's going to be halfway between 10 and 12, so it's going to be about here. And they're quite forgiving as long as they understand the point you're trying to do. If you're slightly off it, they are quite forgiving with that. Okay, so 120 is halfway between 80 and 160, and it's going to be 18 tall, which will be here. And 200 is going to be up to 6. So let's plot these 8, 6, 4, 2. And so 6 is going to be here. Now we haven't finished yet. We do need to join them up with straight lines. So let's just do that to finish off the question. And there we go. That is a frequency polygon. The important thing to remember with an estimate question is that you don't get any marks for getting the exact answer. So even if this does come up on a calculator paper, then you won't get any marks for getting the right answer. It wants you to estimate. Normally, that means to round everything to one significant figure. Now, there are some exceptions to that. Square roots are an obvious one. If you've got root 82, you won't make that, I should put squiggle lines, you won't make that root 80, you'd make that root 81, because then you'd be able to say, well, that's roughly 9. Anyway, there are some small other exceptions. So let's go through this and let's convert these all to one significant figure. And if I draw some lines in, then that might help me. The line for the first one will be between the 7 and the 3, so that will just be 7. For the next one, the line will be after the 1, so that would be 200. Ooh, switch that back. Get all in the same colour, so that would be 200. Now, this is where some people make mistakes. They think that will round to 0, but significant figures ignore any zeros. It's the first non-zero digit you start counting. So the line will go after the 4. So that will round to 0.5. Okay, now we can times the tops together, or times the two numbers at the top together. So 7 times 2 is 14, with 2 zeros, over a half. And all we can do here is just times the top and bottom by 2. So I can times 14 by 2 to get 28. So 1400 times 2 is 2800. And the bottom times 2, well, that's just 1. So the answer is just going to be 2800 or 2800. Now, the point of estimation is you should be able to do it in your head. You have to write down the working out still, but the point of estimation in real life is when you don't have a calculator. So if you're finding something that you've got to do a little grid or something, or work it out a long way, then chances are you haven't estimated enough. This question is just asking you to work out 13% of 2680, then work out 8% of 3114, and then write down which is the biggest, okay, which person gave the most. So first of all, we want to do 13% of 2680, and since it's a calculator paper, then we can do that by just converting the percentage into a fraction. So percent means over 100, and timesing it by the amount. So on my calculator, I will do 13 over 100 and times that by 2680. And it might give you a fraction, just press the S to D button, and that gives me 348.4. And in money, that's 40, because obviously we do 2 decimal places for money. And I haven't shown the examiner who that is, so I'm just going to show the examiner that that's James we're working out. So on to Paul next. So we want 8% of 3114. So we're going to do 8 over 100 times 3114. So fraction button, 8 over 100, or you could do 8 divided by 100, gives you the same answer, 3114. And that's going to be £249.12. So obviously James gave the most because that's the biggest number. So my answer will be James. And it says who gives the most to charity and by how much. So we need to work out by how much. So 348.40, take away 249.12. So 348.4, take away 249.12, and that gets me 99.28. So it's £99.28. Okay, so the numbers in this question seem a bit daunting, but the process is always the same with this type of question in ratios. The first thing you've got to realise is, are you given a total amount or are you given an amount of food or amount of drink? Where it says in total, they spend that amount, so it's a total amount. So step 1 is to work out how many parts you have altogether. So for food it's 39 and for drink it's 4. And this will be a calculator question, so why not use the calculator even though we can do it in our head. 43 parts. So we've got 43 parts. The next stage of this is to work out what one part is worth. So one part is worth how much? Well, you get the amount and you divide it by the number of parts. You're splitting the amount of money between 43 parts. So 11911 divided by 43. And I get £277. So each one part is worth £277. Now let's read the question. Find out how much money is spent on drink. Well, drink is this one here. And the order which they are in the question, food, drink, is the order which the ratios are. So food, then drink here. So there are 4 parts. So we're just going to write drink. So if each one part's worth 277, we're just going to do 4 lots of that. And I might as well do it in the calculator, times by 4. And that's going to be 1108, so 1108. With best value questions, which this is one of, there's normally multiple ways of doing it. Either you get the price per item, or you get how much of the item you get for 1 pence, or you get them to so that they're the same amount of items and then you compare the prices. Now this one asks for the price per tissue, so that's the way we've got to answer this question. So we're going to have tissues on the left hand side and price, and I'm going to do it in pence because it's normally a lot easier to work out when it's in pence. I'm just going to draw a line down the side. So we're going to start off with the box of 24 and it costs 802 pence. Now to get one tissue I'm going to divide both sides by 24. So if I divide both sides by 24, I get one tissue. So I do 802 divided by 24, and I get 33.416 recurring. Okay, let's try the next one. So that's one done. In fact, if I draw a line, then I can show that I've done that. Okay, so the next one is 20 tissues, and that costs 689 pence. So this time I'm going to divide both sides by 20, so I know how much one tissue costs. So 689 divided by 20 on the calculator, and I get 34.45 pence. Okay, and the last one, let's draw our line. So the last one's 15 tissues, and it costs 538 pence. So this time I'm going to divide both sides by 15 to work out one tissue. Okay, so 538 divided by 15, and this time I get 35.86 recurring. Okay, so first of all let's get the price in. So it says rounded to 2 decimal places. Okay, so this first one is 33.42 because that one moves up. The 20 tissue box is 34.45, and the last one is 35.87 because that 6 would round up. So which one is the best value? Well, if you have a look at the 24 tissue box, it's only costing 33 pence, just over 33 pence, whilst the 20 tissue box costs over 34 pence and the 15 tissue box costs over 35 pence. Well, which one would you rather buy? Well, I'd rather buy the one that the tissues cost the least. So the best value is the 24 soft tissues. Now, in your answer, make sure that you write exactly the same as in the question so that it's absolutely clear which one that you think is the best value. Now, if you worked the other way, if the question didn't specify how to do it and you were working out the amount of tissues you get per penny, then obviously it works the other way. You want the biggest number because you want the maximum amount of tissues per penny. So just be a little bit careful of that. Okay, for this question we're asked to find the cost of the toffees and the fudges. Now, if we imagine that we had 2 toffees and 3 fudges, how would you work this out? Well, the cost would be 2 times 50p, and then we would add 3 times 70p. The problem is that 2 and 3 I've just made up, so that's not going to be the answer to this question. What it says though is that it wants toffees to be called T and fudges, the amount of fudges, to be called F. So instead of 2 toffees we have T toffees, and instead of 3 fudges we have F fudges. And in algebra we always put the number before the letter and we don't show the times sign. So it's 50t plus 70f. Now be careful, it does want the cost in pence, but sometimes it wants it in pounds. So if it wants it in pounds, it would be 0.5t plus 0.7f. So the answer is C equals 50t plus 70f. And that can be either way around. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Ooh. Always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what 1 part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the 2 together, it's 102. So there are 102 sweets altogether. Okay, I understand the temptation in this question to say that the answer is 0. Please do not write that. Anything to the power of 0 is not 0. Anything to the power of 0 is 1. Now you can think about this. If you do x to the power of 5 divided by x to the power of 5, then the rule is that you take away the indices when you divide them, so it's x to the power of 0, and we know that any number divided by itself is always equal to 1. So the answer to this question is always going to be 1. Just try and remember that. Anything to the power of 0 is 1. Okay, so for this question we need to work out the length of the arc, which is around here. And then we need to work out what this and this are. So we're going to do arc first. I'm going to show the examiner that I'm doing the arc first. Now the distance of the arc is the total circumference of the circle times by the fraction of the circle we've got. So you want to work out what the fraction is of the circle and times it by the circumference of the circle. So to work out the fraction of the circle we've got, well, we've got 146 degrees and there are 360 degrees in total in a circle. The formula for the circumference of the total circle is pi d, or 2 pi r, Well, here we've got a radius because it's halfway across the circle. If you imagine the whole circle looks something like that, then the 37 is the radius. So we need to first of all double the radius to get the diameter, and so we're going to do pi times 74, which is twice 37. Okay, so we type that all into our calculator, so I press the fraction button, 146 over 360 times pi times 74. And it gives me in terms of pi. I don't need it in terms of pi, I just need it as a decimal. So 94.2826 blah blah blah. Now that's for the arc length, but we also want to know what this distance here is. Well, we've already got that one. And what this distance here is. Well, they are both radiuses, or radii we call it. So that's also going to be 37 meters. So to work out the perimeter, I'm just going to get that 94.2826 blah blah blah, and I'm going to keep it in my calculator, and I'm going to add 37 and add another lot of 37. So add 37, add 37, and that gives me 168.2826 blah blah blah. Once it's two decimal places, so line goes down here, and we've got 168.28. Now just be careful that you add on the extra bits. When it asks you for a perimeter, just make sure you've gone the total distance around the shape. Put a dot and just draw with your finger around the shape to make sure you've got all the distances. Okay, so this question is about Venn diagrams, and it says there's 37 students in total, and it says 10 only like the red car, so 10 only like the red car, 9 only like the blue car, and 8 said they liked the red car and the blue car, so 8 in the middle there, and those are the values for A, B and C. Now it says how many students did not like the red or the blue car. So if we add all those together, we get 27, but there's 37 students in total. So if we take them away, we get the answer of 10. So, and we can actually show that on a Venn diagram on the outside, like that. So let's fill in my answers, 10, 8 and 9. Okay, it says, a student's chosen at random to discuss their views. What's the probability the student liked the red car? Well, let's have a look. There's 10 people who only like the red car, and there's 8 people who liked the red car and the blue car. So in total, that's 18 people who like the red car. Just 8 of them happen to like the blue one as well. And in total, there's 37 students. So it would be 18 over 37. Okay, so to do this question, I'm going to start off with a number line. And I'm going to put the number given to us in the question in the middle. So 89.6. Now it says it's the nearest tenth of a second. So what I want to do on the left hand side is put the next number down. So what could it have rounded to if it was slightly less? Well, the next one down would have been 89.5. And the next one up on the other side would have been 89.7. Now to find the bounds, we just find the halfway points. And this left hand one will be the lower bound, the right hand one will be the upper bound. So that's going to be 89.55 and 89.65. Now it says it wants it as an error interval and use t for the time. So we put t in the middle, then we put the greater than sign on the left hand side, and then just the normal inequality on the right hand side. Now these two signs here will always be the same. Okay, so when you're asked to do an error interval, it's that way around. So we're going to do our 89.55 on the left hand side and 89.65 on the right hand side. Now the reason why the inequality has an equals underneath it on the left hand side is it can be 89.55 and still round to 89.6. The reason it doesn't have one on the right hand side is 89.65 would have rounded to 89.7. So if you just remember, the things in the blue circles are always that way, and the letter it asks you for, just put in the middle. If it doesn't ask you for a letter, you can just pick any letter you want. You can call it X or something. And then the lower bound is on the left hand side, and the upper bound is on the right hand side. And the lower bound's always here, and the upper bound's always here. Okay, so this question, it looks like a standard bearings question, but something you might notice is there's no angles in it. So if there's no angles in it, we need something else, and that something else is going to involve the right angled triangle here. So we can see there's a right angled triangle here, and we know that when we've got right angled triangle, we've got two sides, we can find an angle with trigonometry. I'm going to call this angle X. Now to find X, we need trigonometry, and to do trigonometry, we need to label the sides. So we've got the opposite here, which is opposite the angle we want. We've got the adjacent here, and we've got the hypotenuse here. Well, the hypotenuse is no interest. We're not looking for it, and we're not given it. So it's O and A. So writing Socrator, so Toa. Well, we're not interested in the H, so it's not going to be So, it's not going to be Ka, so it's going to be Toa. So Toa stands for tan X equals opposite over adjacent, and the opposite is 47, and the adjacent is 72. Now we want to work out what X is, so to do that we want to inverse tan both sides. Okay, let's just scroll down. Okay, so on the calculator you want to click Shift or the equivalent on your calculator and then tan, and then you press the fraction button, 47, and go down, 72. Just don't forget to close the brackets. Every time you click tan or inverse tan, it opens a set of brackets. Just make sure you shut them. Let's press equals, and that equals 33.1356, blah blah blah. Okay, let's have a look. So X is 33, but we still haven't got a bearing. What we can do is work out what this one is, and I'm going to call that Y. So to work out what Y is, it's going to be 33.1. Well, we're looking for nearest whole number, so let's call that 33. And then we're going to add the right angle here. Now, the reason I know this is a right angle here is because it says that he heads west and then south. So I know that both the angle here and the angle here are going to be right angles, because the angle between all four, north, east, south and west, all four directions are going to be right angles. So I'm going to add 90. And you can do this in the calculator, or you can do it in your head. I'm going to do it on the calculator. 123. Okay, now bearings, something that we've got to remember, are always from north going clockwise. So it's always going to be like that. It's going to be that angle there. So to do that, we're going to do 360. We're going to take away the 123 because that's what we don't want. So on the calculator, 360, take away 123, and that's 237. So the answer is 237 degrees. To solve a quadratic, first thing you need to do is get it equal to 0. So I'm just going to write it out first of all. And then I'm going to draw my lines down so I can show the examiner what I'm doing. So the first thing I'm going to do is take away 6x both sides. So it's going to be x squared plus 7x minus 14 equals minus 10. And then I'm going to get rid of that minus 10, so I'm going to add 10 to both sides. So it's going to be x squared plus 7x minus 4 equals 0. Now the first thing I do is look at it and go, can I factorize it? Well, given the fact that it wants an answer correct to 2 decimal places, that's a bit of a hint that you're not going to be able to factorize it. Because when you factorize it, you'll normally end up with a much nicer number. And if the coefficient of x squared is 1, you'll end up with an integer. So we're going to have to use the quadratic formula, and there are other methods, but the most common one is the quadratic formula, so that's what I'm going to do. So the quadratic formula says x equals minus b plus minus the square root of b squared minus 4ac over 2a. Now you might say to yourself, well, what is a, b and c? Well, hopefully you don't, because if you're doing this question, I would assume you do know what the a, b and c are. But for those of you who don't, a is the number before the x squared, b is the number before the x, and c is the leftover number. Now, the number before the x squared is 1, because there's no number there, so it's 1. The number before the x is 7, and the number on its own is minus 4, and that's really important that you understand that that's not 4, that's minus 4. So when I substitute it in, so b was 7, so it's minus 7 plus minus square root of b squared, well that's going to be 7 squared, so I know that's going to be 49, so I might as well write 49. Now it's minus 4 times a times c. Now a is just 1, so we can ignore that. Minus 4 times c, which is minus 4. Well, minus 4 times minus 4 is going to be a positive 16 over 2 times 1, which is just 2. Now you could, at this very early point, just type this into the calculator and that would be absolutely fine. Just make sure you put brackets around this and put any negatives in using the special minus button, which on the Casio calculators is 2 spaces above the 7. Okay, let's keep going there. So I might as well just type this in now. Well, I can finish it off. I can do the 49 plus 16 without a calculator. So let's keep going. Let's do it without a calculator for a little bit. So that's going to be square root of 65 over 2. Okay, this plus minus thing here just means that there's going to be a plus answer and a minus answer. So we split it up into 2 at this point. We have x equals minus 7 plus root 65 over 2, and we have x equals minus 7 minus root 65 over 2. And what you can do is just type that into your calculator, press the fraction button, then minus 7 plus root 65 over 2, and then you press equals, and that gives an answer for us. So I'm going to put that straight in, I think. No, I'm going to show the examiner. I know. I'm going to show the examiner. So 0.531128 blah blah blah. And then what you can do is on the Casio calculators you can just use the cursor button, which is the big blue round one, to move across, go to that plus, delete it, and change it for a minus. It saves you having to write the whole thing out again. And then let's have a look. And if yours comes up as a fraction or something, just press the S to D button. It converts it. That's minus 7.5531128 blah blah blah. Okay, it says to round it to 2 decimal places, does it? Yeah. So we want 0.53. So 0.53. What else? Minus 7.53. So minus 7.53. There's our answers. So what this question is asking us to do is find the inverse function. That's what the f to the power of minus 1 means. And there's a really easy way of doing this. If we rewrite the function as y equals 4x minus 5, to find the inverse of it, we just literally swap the y and the x around. So x goes here and y goes here. Then the task is to try and get the try and get the y equals. Okay, try and make y the subject. So I'm going to go put my lines down. So the first thing I need to do is add 5 to both sides. So we're going to have x plus 5 equals 4y. And next thing I need to do is divide by 4 both sides. And the way of doing that really is just with a fraction. So y is x plus 5 over 4. Now we made up y. Y represented the function initially, and then it represented the inverse function essentially. So all we need to do is finish that off. So f to the power of minus 1 of x equals x plus 5 over 4. If I just put that into the answer box. Now there are other methods, but I've always found just writing y equals and swapping the x and the y around and making the y the subject by far the easiest method. But if you've got a different one and it works, stick with it. Okay, so for this question, understanding of the formula of a circle is critical. So formula of a circle is x squared plus y squared equals r squared. So it looks very, very similar to the equation given to us here. So if I rewrite the equation given to us, and instead of 4 I write 2 squared. Okay, and that's a perfect match for the equation of the circle. So we've got a circle with radius 2. So it's from the origin, which is here. Let's do this in red so it shows up. And it will pass through, it will have a radius of 2. Now, I don't have a compass, but when you're doing this, do it with a compass, and you're going to see how rubbish I am at drawing circles. That wasn't bad, although I think it's just going to get worse. It's probably the least pathetic circle I've drawn, but use a compass in the exam. Measure out the radius on one of the axes, and then just draw a circle, and that's 4 marks. Okay, so in this question we're asked to enlarge shape A by scale factor -2 with the centre of enlargement 2,5. So normally we'd first of all put the centre of enlargement on, but it's already done for us. So what I need to do now is draw my ray lines, but because it's negative we know they're going to go through the centre of enlargement. So I'm going to draw my ray line. I don't need to do the bottom right one because it will essentially be the same thing. And let's do this one. Let's try and get it as perfect as we can. So it should be something like that. Okay, now the next thing to do is count how many squares we went away. So I'm going to start with the bottom left point. So we've got 1, 2, 3, 4 to get to the centre of enlargement. So if it's -2, we're going to go another 4 twice. So 1, 2, 3, 4, 1, 2, 3, 4. So we end up here. Okay. For the next one, let's do the bottom right one. So we're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we're just right on the edge there. Okay, let's do the last one. So this time I'm going to count the diagonals, and if you had a ruler you could just measure it out. So 1, 2, 3, 4 diagonals. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, and now we need to connect them all up. So let's connect them all up. And probably it will say label it B, yeah. So label it B. And always check the width of A was 2 and the width of B is 4, so that's good. The height of it is 4, and so the height of B should be 8, which it is. And it looks unusual because for an enlargement you're used to it being the same way around, but for negative enlargement it basically just flips it. There are a few different ways of answering this question. I'm going to show you what I feel is the easiest technique, but if you've got a different technique you get the same answer, then stick with it. This question will all be about multipliers and understanding how to use them, but the difficulty in this question is we're finding out how long it will take to get to a certain point, which is a big twist in this question, and we're not given a quantity. Now, whenever you're not given a quantity, one method of being able to do it is by putting in your own quantity, and the easiest quantity to put in is the number 100. So I'm going to pretend that the population of the town at the start is 100. Now, this question, as I said, is all about multipliers, so we need to figure out what a decrease of 6.5% as a multiplier is. And to do multiplier, you start off with 100%, you do whatever the question's saying, so this time we're decreasing by 6.5%, and this will be on the calculator paper, so you might as well use your calculator to do 100 take away 6.5, and hopefully the answer is 93.5%. And to convert it into a multiplier, you just divide by 100. You're just converting it to a decimal, but the paper will call it a multiplier. That would be 0.935. So whenever I times something by 0.935, I've decreased it by 6.5%. Okay, so we've got 100. And what I want to do is figure out how many times I need to multiply it by 0.935. Okay, so there's a power here which we don't know yet, to get the answer that is less than 47% of it. Well, the reason I pick 100 as my quantity I've made up is because 100 is nice and easy, because 47% of 100 is 47. So we need it to be less than 47. Now, what I do on my calculator is I type in 100 and I times by 0.935 and I get the answer of 93.5. Now, what I'm going to do now, and that's one time, what I'm going to do now is press answer times 0.935. And what that will do is allow me to go through this same calculation as many times as I want by just pressing the equals button. So I'm going to press the equals button once and I get the answer of 87.42. So I've done twice in total so far, and I can leave a little tally mark here. I press it again and I get 81.7. Again, 76.4. Again, 71.4. Again, 66.8. Again, 62.4. So I'm getting closer. Again, 58.4. Again, 54.6. Again, 51. I'm getting close. Again, 47.7. So I'm getting very, very close, but I'm not quite there yet. And I press it one more time and I get 44.6. So in total, I've done it 12 times. Now, I'll always want to check that because my counting is not necessarily the best when under pressure. So what I'm going to do is I'm just going to do 100 times 0.935 to the power of 12 to check that I've got this right. So 100 times 0.935 to the power of 12, and I get 44.64. And I'm just going to check that that was the first time it went under. So I'm going to do to the power of 11. And what I can do is just scroll through my working out on the calculator and change the 12 to 11. And press equal. And that's 47.744. Blah, blah, blah. Okay, and each of these are rounded. Okay, so it's going to take 12 years because 11 years gets us close but not quite over the line. It's the 12th year that it dips below 47%. Now, as I said, there are different methods. You don't need to include the 100 as a made-up value. What you can do is just look at the multiplier and wait until the multiplier is 0.47 or below, below 0.47. And the multiplier would go down to 0.4464, blah, 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 blah. That's absolutely fine method. And there are other ways of doing divisions, which I'm not going to go into because you don't need to go that far. Because when you hit A-level, there's a much, much better way of doing it, but we don't go through it at GCSE. If you wanted to look into it, it's to do with logarithms, but we won't go into that. Okay, so this question looks quite simple, but actually it's going to take a bit of time to sort out. So first thing I'll do is do a little sketch. I'm going to do it up here. Since the y's are mainly negative, in fact are negative, both negative, I'm just going to show the bottom of the graph. So at point 7, we're at minus 17, which I'm going to say is here. It's a sketch, so it doesn't have to be perfect. And at point 19, we're at minus 11, which I'm going to say is here. Okay, this is called line AB. Now we're asked for the perpendicular bisector. Now perpendicular means it's going to hit that line at right angles. Bisector means it's going to cut it right down the middle. So I'm going to start off at the middle of the shape and draw a quick sketch there, like that. Okay, I'm going to call this M here, and I'm going to call this line C, just so I can reference it in my working out, and it makes it a bit clearer. Now, there are two things I need to find out to find out the equation of point C. I need to find the gradient of point C, and I need to find the y-intercept. The gradient is going to be the first thing I'm going to have to find, and then I can work out what the y-intercept is, and then write the equation of line C. So, two things I need to work out for line AB is the gradient. So the gradient is going to be change in y over change in x. So the change in y is minus 11 take away minus 17, and the change in x is 19 take away 7. Okay, so we've got minus 11 and then effectively plus 17, which is 6, divided by 19 take away 7. Okay, 19 take away 7 is obviously 12, so 6 divided by 12, which is a half. So the gradient of that is going to be a half. Okay, next I need to find the midpoint, because we know that that's also a point on line C. Okay, so the midpoint is going to be the average of the x's, so 7 plus 19 over 2, and then the average of the y's, so minus 17 plus minus 11 over 2. So we're basically just finding the halfway points. Now, obviously 7 plus 19 is 26, divided by 2 is 13, but you might have just noticed that 13 is halfway between 7 and 19. Same with the others. Obviously, we could do the same thing. Halfway between the two of them is going to be minus 14. Okay. Now, you might be wondering, well, why did we find the gradient of line AB? Well, perpendiculars have a kind of weird connection where if you multiply both their gradients, it equals minus 1. Now, the way we use this is to convert a gradient to a perpendicular gradient. We do two things. We find the reciprocal of the gradient and we times it by minus 1. So to find the gradient of line C, what we're going to do is flip it. So the reciprocal of half is 2 and times it by minus 1. So it's going to be minus 2. Now, a way of checking that is if you multiply the two gradients together, you should equal minus 1, which a half times minus 2 is minus 1. So we've got the gradient. Now we know that a formula for the equation of line C is y equals mx plus c. We actually know the gradient and we know a point on that line, which was the midpoint of line AB. So we're going to feed in the coordinates. So it's minus 14. We know what the gradient is, minus 2. I'm going to put this in brackets, times the x coordinate, which was 13, plus c. And we just solve this to find out what c is. So minus 14 equals, and that's going to be minus 26 plus c. I'm going to add 26 both sides. And if this is on the calculator, then obviously always use your calculator to be sure. So it's going to be 12 equals c, or c equals 12. So therefore the equation is in the form y equals mx plus c. It's going to be y equals minus 2x plus 12. First thing I do with this question is just write the numbers out. They're a bit small in the question. Now with all sequences, we're interested in what it goes up in. So we're interested in what these go up in. So if you've got a calculator, you can just do 25 take away 13. If it's on an uncalculated paper, then you can just quickly do it in your head. And I'm going to do this for a few of them. Now you might notice straight away that the next one goes up in 18. Well, let's have a look at the next one. That goes up in 24. And the last one goes up in 30, which is what we'd expect. So they're not going up by the same amount. Now when they don't go up by the same amount, we need to have a look at the second difference. If they don't go up by the same amount in the first difference, that means it's not going to be an arithmetic sequence. We're not going to use the standard linear nth term, the one that you're probably used to. For a second difference, it's going to be a quadratic. Let's check to see if there's a second difference. So that's add 6, this is add 6, and this is add 6. So we know it's a quadratic sequence, so it's going to involve an n squared somewhere. Right, the step that people have difficulty with is you get the second difference and you halve it. And that's all you've got to do. Now, that halving, the dividing by 2, won't ever change. You'll always halve it and you get the number 3. This 3 is going to be the coefficient of the n squared. So I can fill that into my answer now. Now the problem is we don't know what else we need. What we need to do is write out the sequence 3n squared. So let's number the terms. So we've got the first term, second term, third term, fourth term, and fifth term. And so we've got our sequence, which is, I'm just going to copy this out again, 13, oh, alright, 35, it's 25, 43, 67, and 97. And we're going to write out the 3n squared, which we've just discovered. Now, that means we just square the sequence number and then times by 3. So 1 squared is 1, times 3 is 3. 2 squared is 4, times 3 is 12. 3 squared is 9, times 3 is 27. 4 squared is 16, and times that by 3 is going to be 48. 5 squared is 25, times 3 is 75. Now what I want to do next is I want to subtract them. I want to subtract the sequence. I want to do the sequence take away the 3n squared. We know that 3n squared is a part of it. We need to just take it away so we know what's left. So 13 take away 3 is 10. 25 take away 12 is going to be 13. 43 take away 27 is going to be 16. 67 take away 46 is going to be 19. And 97 take away 75 is going to be 22. Okay, now we end up with a little sequence here. Okay, we've got 10, 13, 26, 10, 13, 16, 19, 22. Now we find the difference in that. So that's a plus 3, plus 3, plus 3, plus 3. Now that's a linear sequence. Now we've got to find the nth term of it. So to do that, we find the 0th term. So we go back 1, we subtract 3. And that tells me, so I'll say linear. So that's going to be a 7. So we know we're going to add 7. And we know it goes up in 3, so it's going to be 3n plus 7. So we got our 3n squared already, and we just need to add 3n plus 7. So the first thing you need to do is find out what the quadratic sequence is, the quadratic bit of it, the squared bit. Then you've got to find out what the linear bit of it is, and then just add them together. Okay, so for this question, this is all about linear, area, and volume scale factor. So, with this question, from B to A, we can work out the linear scale factor. So what do I times 5 by to get to 10? So the linear scale factor is going to be big divided by small, which is 2. Now the area scale factor is always the square of the linear scale factor. So we square it and it's going to be 4. The volume scale factor is always the cube of the linear scale factor. So we cube the linear scale factor and it's 8. So with this first question, it says cuboid B has the volume of 80. So if B has 80, the volume of A is going to be 80 times the volume scale factor, which is 8. So that's going to be 64 with a 0, so 640. And it's that simple. This one here, it says cuboid A has a total surface area of 440. So work out the surface area for B. Now this is surface area this time. So it's going to be 440. Now because we're going from bigger to smaller, we're going to divide by the scale factor. And it's the area scale factor we need, which is going to be the 4. So we do 440 divided by 4, which is hopefully 110. And it's that simple. So you just got to remember that if you have a linear scale factor, you square it to find the area scale factor, and you cube it to find the volume scale factor. Okay, so this question seems really complicated because the just sheer amount of words, but actually it's quite a simple question when you get your head around it. So the first question, we're looking at a bag or 2 bags of letters and 1 bag of numbers. And so there are 26 letters in the alphabet, so there's 26 options for this first bag. There will be 26 options for the second bag, and numbers from 0 to 9. Now we've got to be careful here because 0 is counted, so there are 10 numbers in that bag, because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, but there's also 0, so that's 10 in total. And to get the amount of combinations, all we do is 26 times 26 times 10. And we'll have a calculator for this, so 26 times 26 times 10, which is 6,760, which seems quite a lot, but there we go. This next one is, so he wants to use 4 digits, but limit the combinations. So we just got to read the question. His letter bags now contain the letters A to F, so that's A, B, C, D, E, F, which is 6. So these both will contain 6. And only contain even numbers greater than 0. Now, these are the same bags as before, so we only had the numbers from 0 to 9 before. So the even numbers that are greater than 0, so it's 2, 4, 6, 8. So there's 4 combinations. So there's 4 numbers those can be. And so find out how many different passwords if they're arranged like this. So 6 times 4 times 4 times 6. So 6 times 4 times 4 times 6, which is 576. Now that might seem confusing that there's an extra digit to the password and yet less combinations, but if you think about it, there's significantly less letters and less numbers, so that's why it's a much lower number than part A. Okay, so we've got an exponential graph. The reason we know that is because it's to the power of x, and we're given 2 points on it. So the way I'd start this question is to just look at this point here and substitute in the values. So we've got 15 equals ka, right, to the power of 1, which is just a. Then underneath it, I'm going to write this one here. So it's 135 equals ka to the power of 3. Now I'm going to think about what I do to the right hand side here to get from ka to ka cubed. Well, I'm going to times it by a squared. So I think, well, what do I do to this side? So I get my calculator and I do 135 divided by 15, which is 9. So I'm going to times it by 9. Therefore, a squared must be equal to 9, because we're timesing the left hand side by 9 and we're timesing the right hand side by a squared. So we then square root that. Now this is where it gets interesting. You actually get a positive and a negative 3, but the reason I know it's positive 3 is because if it was a negative, the actual graph would look like this. So if it's a normal exponential graph, which this is, because this passes through 1 here, then it's going to be a positive power. If it's a negative power, it means it's a fraction, and therefore it will never quite get to the y-axis. But you don't need to worry about that. If this was asked, it's normally going to be a positive, but having said that, it might not be. So anyway, I then use that a into the first equation, so 15 equals k times a, well that's going to be 3k, and then divide both sides by 3, and you get k equals 5. So k equals 5 and a equals 3, and I just need to check that. So let's do the second equation, so 5 times 3 cubed. So 5 times 3 cubed is 135, so I know I've got it right. Okay, so this is a question on iteration, and we're given the iterative formula for a situation. Now, iteration is all about trying to find an answer, and it's a method in maths that bounces above and below constantly the correct answer, and it just gets more and more closer and closer, but it doesn't quite ever get there. It will just get more and more accurate the more times you do it. So we're looking for when to stop, and that's given here, just to 2 decimal places. So the formula is given here, and this is the only bit we need here, as well as this bit, the starting number. And in my calculator, I'm going to type in 5 minus, well, actually, no, I'm not. I'm going to press 2 and then equals. And the reason for that is it tells my calculator to use 2 if I use the answer button. Next thing I'm going to do is type in 5 minus square root answer. Now, when I press equals, the calculator will remember that the 2 is the answer and use a 2 here. Now, you might think that's a lot of effort just when I could have pressed a 2, but you'll see what the benefits are after this first run. So when I press equals, that gives me my first number, and if it comes up as a third or something on your calculator, just press S to D. So that gives me 3.585 blah blah blah. Now the beauty of these calculators, these modern calculators, is if I press equals again, it will use the 3.585 number and put it back into the equation. So all I need to do now is just press equals, and it gives me 3.1063 blah 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 blah. Again, equals 3.2375 blah blah blah, equals 3.2006 blah blah blah, equals 3.2109 blah blah blah, equals 3.2080 blah blah blah, equals 3.2088 blah blah blah. Now you stop when you get the first repeat of the accuracy that you're looking for. So if you look, this is the first time I've got the same answer twice, 3.208 blah blah blah. So it says it wants the solution correct to 2 decimal places. Now 3.20 is not going to be the right answer, because if I have a look, the next one is an 8. So my answer will be 3.21. The first thing to notice with this question is that to find a distance of a velocity time graph, you've got to work out the area underneath the curve. Now at A level there are much easier ways of doing this, but we at GCSE have to do this using the Trapezium Rule. Now the Trapezium Rule goes as follows. You're going to carve that curve, or the underneath of that curve, up into trapeziums to try and estimate, and this is what it asks us to do, the area underneath it, therefore the distance. So it says it will always give you hints about what it wants you to do. So it gives us a hint saying that it wants it between 2 and 10, but it wants it in 4 equal intervals. So if I do 2 and 10, so we can get started. Now let's have a look and see how many squares there are in between there. There's 8. So if we want 4 equal intervals, we're probably going to go up in 2s. So let's try 2s and hopefully it will work nicely. Now we haven't created trapeziums yet, so let's create trapeziums now. So we're going to create trapeziums for these 4. There we go. Okay, let's try and get the heights of these trapeziums, and I normally draw it onto the graph itself. It's a little bit easier to get my head around. So that's, I think that's 11. I think that's 6. I think the height of this one is probably, because I've drawn it badly, I think it's 3. Height of this one is 2, and the height of this one I think is 3. And the width of them is 2, so all of them is 2. Okay, so we need to remember how to work out the area of a trapezium. It's half a plus b h. Now this is quite misleading because h actually used in the trapezium rule is the width of the trapezium. It's because the trapeziums are kind of on their side. So h is always going to be 2 for these. So what I would do is just number the trapeziums that I'm doing. So I'm going to do number 1. Now number 1 is going to be half 11 plus 6, because A and B are the ones on the left and right of the trapezium, times 2. And I can use my calculator for this, so it's going to be 17 divided by 2 times 2. I don't know why I'm dividing by 2 and timesing by 2. It's just going to be 17, because the half and the 2 will cancel out. So the second one is going to be half, and this time it's 6 plus 3 times 2. Well, we know the half and the 2 will cancel out, so that's just going to be 9. The third one, the third trapezium, and if you want to, you can actually just number them on the actual thing itself to show the examiner, yep, this is the one I'm trying to work out. So that's going to be half, and what is it this time? 3 plus 2 times 2, which is just going to be 5. Let's just scroll it down a little bit. So the fourth one is going to be half 2 plus 3 times 2, which is also going to be 5. So to work out the total distance, 7 plus 9 plus 5 plus 5, 17, sorry. So 17 plus 9 plus 5 plus 5. I don't know why I'm using a calculator for this as well, but it's here, so we might as well use it. So it's going to be 36. Now commonly with this question you're also asked whether it's an overestimate or underestimate. If you have a look at the trapezium, this bit here and this bit here, we've counted that as area, and actually there's little thin strips down here. We've counted as area that actually isn't area. So this one will be an overestimate. If your trapezium goes the other way and it doesn't quite hit the curve, then it's going to be an underestimate. Right, so this question looks a bit daunting, but if we break it down, it is kind of simple as long as you can kind of view things in 3D. There is a length that we need before we start answering what the length of AM is, and that's this length here. Now I'm going to call this length x. I'm going to use Pythagoras to work out what x is, and then we're going to work out what y is, which I'm going to call the height. In fact, why don't we call it h for height? That's probably more sensible. By using the value of x, or using half the value of x, using that 5 up the side, and using Pythagoras to work out what h is. Okay, so I'm going to draw out the two right angle triangles I'm using. triangle DEB first of all to work out what x is. So that's DEB, and we call this one x. This one is 4 centimeters, and this one's 3 centimeters. And then we're going to work out what the height is. So it's a at the top, is it? Yeah. So it's A, M, D. Now we know this one at the bottom is going to be half of x, and we know at the top it's 5 centimeters. And this one we just go call h. Okay. So we're going to work out what x is first, and if you don't know how to use Pythagoras, there's loads of stuff on the site on how to do that. Now it's a 3, 4, 5 triangle actually, so let's do this all anyway. 9 plus 16, root 25, and that's just actually going to be 5. I would leave it as a root if it doesn't work exactly, so I'd leave it as a square root. Okay, so we know what this one's going to be. It's going to be x divided by 2, which is 2.5. Okay, so to work out what h is, I'm going to do the hypotenuse squared minus that length that we've just found out squared. And just get my calculator. Root 25 take away 2.5 squared. And it's 4.330 blah blah blah. So it's 2 decimal places, it's 4.33. And it's probably sensible to check that makes sense. Have a look at the numbers we've got in the question. Imagine a 3 by 4 by 5 rectangular based pyramid. Does that kind of make sense? And to me, yeah, that kind of makes sense. It's less than the 5 here, and since 5 is the hypotenuse on that triangle, it needs to be less than that. So yeah, it kind of makes sense. Okay, so we've got a linear and a quadratic equation, and so the way of doing these is slightly different. And if you notice that each equation has this y in, now y is going to be equal in both equations, so what we do is we just get the equations here equal to each other. So we've got 2x plus 11 equals x squared minus 5x plus 4. Now we can get them equal to each other because y, if we're solving, y is exactly the same thing. So we're just getting them equal to each other because they both equal y. And then we would need to move that around so that we have equal to 0. So we're going to take away 2x both sides. So we've got 11 equals x squared minus 7x plus 4. And we're going to take away 11 both sides. So we've got equal to 0, which we need quadratics to be equal to. So was it 4 take away 11, which is going to be 7, so minus 7. Okay, so at this point we're looking at either factorizing, which I doubt is going to work, or using the quadratic formula. I think we're going to need the quadratic formula for this, so we need to remember what the quadratic formula is. So minus b plus minus square root of b squared minus 4ac over 2a. We've got a is 1, b is minus 7, and c is also minus 7. Okay, it's going to take a while. So minus b is going to be just 7, plus minus b squared, which is going to be 49, minus 4 times a, which is 1 times c. So it's going to be, and you can use your calculator for this, so it's minus 4 times minus 7, which is positive 28, so it's going to be plus 28. Okay, over 2. And so 49 plus 28 is going to be 77, so we can rewrite it like this. Okay, this is where we split the two apart. We have the positive version, so 7 plus root 77 over 2, and we have the negative part, 7 minus root 77 over 2. So the positive part, 7 plus root 77 over 2 is going to give us the answer 7.89 to 2 decimal places. Now, at this point, it's still in my calculator. Okay, I don't want to get rid of it because I need to also find out what y is. Now, it says y equals 2x plus 11. So y equals 2x plus 11, which equals 2 times this value in my calculator plus 11. So I'm going to times this by 2 plus 11. And it gives me the answer of 26.77 to 2 decimal places. And those are my answers for now. And y is 26.77. Okay, let's carry on. And I'm going to type that in again. So 7, but this time minus root 77 over 2. And it gives me the decimal answer of minus 0.89. Again to 2 decimal places. So minus 0.89. And similarly, we know that y is 2 lots of x plus 11. So I'm going to times that by 2, and I'm going to add 11. And press the decimal button, so 9.23. 9.23. And that's to 2 decimal places. So it takes a bit of time, but if you make sure you write this part here down, then you can just split it up into a positive and negative. Okay, so this question is involving a probability tree diagram, and if we read the question, it says that the counter's not put back in the bag. Therefore, we know it's going to be conditional. Now, conditional means that the probability of the second event, so taking the second counter, depends on what you did the first time round. Okay, the way probability trees work is you start on the left-hand side, and you have an option. You can either go up if you pick blue, or down if you pick red. Now, because you have to pick one of the options, the two options have to add up to 1. So if blue is 3 over 7, the bottom one must be 4 over 7. Has to be, because then it adds up to 7 over 7, which is 1. Now, if we picked a blue on our first counter, the probability of us picking a blue again is 2 over 6. So therefore, the probability of us picking a red will be 4 over 6. Okay, now let's see where those numbers have come from. It says in the question that there are 3 blue counters and 4 red. Therefore, the first probability of a blue being 3 over 7 is because there's 3 blue counters and there's 7 altogether. The second probability, so if I picked a blue on the first counter, went down, well, if I picked a blue again, to 2 over 6. That's because there's 2 blue counters and only 6 left altogether. So we need to know that to be able to fill out the bottom one. So if I picked a red on the first time round, what's the probability I'll pick a blue? Well, let's have a think. There are still 3 blue counters in there, but there are only 6 left altogether left in there because we've picked a red. So the probability of us picking a red, well, there were 4 before we picked one, but we've picked a red, so therefore there are 3 reds left and 6 left altogether. Now, I'm deliberately not cancelling these down. I could cancel it down to a third, 2/3, half, half, but I'm just going to leave it as it is for now, just to make things simpler. Okay, question B says, work out the probability that the 2 counters picked are different colours. So let's follow our routes along. I'm going to go up and then up, so blue and then blue, blue and then red, red and then blue, and you're always starting from this point here, and then red and then red. Now let's have a look. Blue and blue are not different colours, so we're not interested in that. Red and red are not different colours, but the middle two are. So what you do with probability trees is you start here and you collect all the fractions that you went past on your way, on your journey to the end. So we went past 3 over 7 and 4 over 6. Now the word and there is really important because and in probability means times, and you're always going to multiply them when you're going across a tree diagram. So I'm going to times the tops and times the bottoms. Again, I'm not going to bother cancelling down at this point. Okay, so the other option is I pick a red first and then a blue. So that is 4 over 7 and, mean times, 3 over 6. That's going to be 12 over 42. And normally these two will be the same. Okay, so just be prepared for that. Not always though. Okay, so we had 12 over 42 for the first option and 12 over 42 for the second option. But we can't pick both options, and this is the problem. We've got two probabilities, two answers. Well, we can't possibly have that. The word or comes into effect here. We either pick a blue and then a red, or a red and a blue. And the word or in probability means add. So all we need to do to finish this question is add the two options we had. So when you're going down here and you're collecting all the fractions you got, you just add them together. So we're going to add the tops together, which is 24 over 42. So it's half top and bottom, and let's cancel it down now. 12 over 21, and I think I can divide them both by 3, so it'd be 4 over 7. So my answer is 4 over 7. Okay, so this looks like quite a complicated question. The important part of this question actually is this bit here. Now this looks like it's trying to give you a little bit of help. Actually it gives you a huge amount of help. It's basically telling you that when you add them together, the common denominator will just be a quadratic. Now it might be tempting just to multiply all of this by all of this and kind of get a cubic equation, but actually the answer is saying no, don't do that. The bottom will work if you factorize it. So what we need to do is factorize the one on the right, and hopefully we'll notice something about it. So we've got videos on how to factorize quadratics where a is more than 1, and it's quite a unique method, but I'm going to go through it quickly, but please use the videos for a kind of slower explanation. So what I do is I times together the first and last ones, times them together, and that gives me 48. And then I've got to find a factor pair of 48 that adds together to make the coefficient of the x. So 2 and 24 won't work, 3 and 16. So then I rewrite the 19x as 16 and 3, or 3 and 16, doesn't matter. You get the same answer eventually either way. Then I just look at these two and factorize them linearly, and I just factorize those two linearly. So 8x squared plus 16x, so I can divide out an 8x, and 3x plus 6x I can divide out a 3. And you notice that the bracket here is the same. Then you pair up the bracket that's the same with the bits on the outside, so you get 8x plus 3 and x plus 2. Cool. So I can rewrite that. Now I'm going to rewrite the question. So now it becomes 1 over 8x plus 3 x plus 2 plus 1 over x plus 2. Now you notice that actually that bracket is the same. So all I need to do is times top and bottom here by 8x plus 3. I'm squishing it a little bit. And it will have a common denominator. Right, so I'll rewrite that just to make sure my working out is really clear. So the top becomes 8x plus 3. And the bottom actually is the same as the other side, which is good because now we can add the tops together. So if we add the 1 to the 8x plus 3, we get 8x plus 4, and then we've got 8x plus 3, and then x plus 2. And that's my answer. Looking at the structure of the answer, it looks very much like we're going to have to complete the square. Now, to complete the square, we need x squared minus something. Okay, now we've got 2x squared, and so minus something x. We've got 2x squared minus 28x. So we're close to getting that, but we haven't quite got that. So what we need to do is factorize the 2 out first. So 2 brackets x squared minus 14x. And then I'm just going to add the minus 4 at the end. You could also factorize out the 4 as well, but I'm just going to leave that alone because I'll deal with that later. Now that we've got what we need to be able to complete the square, which is the x squared minus something x, we are going to complete the square. Now to complete the square, and I'm going to do this over here to show you a little bit easier. What you need to do is you need to put the x minus half of the bit here, so it's going to be 7 squared. Now that will get, if you expand that, that will be, or using FOIL, that would be x squared minus 7x plus 49. Now we need the x squared, we need the minus 7x to get the minus 14x, but we want to get rid of the plus 49 that it generates. So we need to take away 49 from it. And that's it, that's completing the square. Okay, so I'm going to replace that with what I've just found out that it is, x minus 7 squared minus 49. Now, I have that minus 49 on the inside of the brackets, and I want to collect that with the minus 4 on the outside of the brackets. So I'm going to just expand the big brackets. So I'm going to times the x minus 7 squared by 2. And I'm going to times the minus 49 by 2. And so I can collect the numbers together. So looking at the question, it says it wants m. M is the thing before the brackets, so m is going to be 2. Now it says that p is a positive. Well, we know that p is minus 7, so I'm going to put minus 7 there. And q, it says, is a positive. Well, we know it's a negative, so it's going to be negative 102.
Well, I hope you found that video useful. If you did, please click like. If you want to see more from us, including the other 2 papers, please click subscribe. We've got loads and loads of stuff on the website on maths.com, which you can go to here, which is completely free. But if you feel you're quite far behind in the maths, or you're not happy with the grades you're getting on maths.com or other mock papers you have, you can try out our premium service, which is mathseffect.co.uk. With mathseffect.co.uk, it's a small monthly fee, and you can do an annual subscription, but if you only want to do it up until November, which makes sense, you can just pay per month. And what it does is it has the whole of the Maths GCSE as a journey, and you go through each topic, mastering it one topic at a time. A lot of the students I talk to say, I really don't know where to start. Like, I keep doing Pythagoras and Trigonometry over and over again, and I don't really know what else I don't know. This is a service which just covers everything. It makes sure you master and you are an expert in every topic in maths. So it's worth checking out. Loads of people have joined already, and if you haven't joined, go to the website mathseffect.co.uk or click the link in the description. That will take you straight there and you can check it out. Otherwise, thank you very much. If you want to leave a comment down below of anything you want us to cover, because we're desperate to help anyone who's being caught up in this terrible situation, which is not ideal for anyone, but equally, like, we all understand why it's happened. But if I was having to resit or having to sit for the first time in November, I would feel exactly the same as you are probably feeling. So if you want to leave any comments down below, and we might release some videos just discussing options that you have open, or whatever it might be. Otherwise, thank you very much, and I'll see you in the next video.